This is Duke University.
Hello everyone, my name is Morgan Irons and I'm a freshman here at Duke. And as you can see by my first slide, I'll be talking about water pollution. And as I talk about water pollution, I want you to think about the question, can you see it? Is water pollution something that you can see as an object? Can you hold it, or do you need like a microscope or something to look at it? So to begin off my presentation, let me begin with a story. Don't go in the water. My parents would yell this at me whenever I tried to go into the water at the beach or tried to jump over the water-filled ditches around my house. I didn't see anything really wrong with jumping in the water, until one day we went to the James River near my house in Virginia. Looking out over the water, I saw 2 dead fish floating in the water. Turning to my dad when I was 8 years old, I asked him, "Why are those fish floating in the water?" He thought about it, and then he said they were probably poisoned by the chemicals in the water. Oh, okay. My 8-year-old mind could not determine the significance of what my dad had just told me. But years later, as I heard more about water pollution, eutrophication, restricted access to clean water, this moment stuck in my mind. Living in Virginia, I've always been surrounded by water pollution. Virginia alone dumps 18 million pounds of waste into its waterways every year, making us the second worst state for toxic chemicals dumped into its waterways. This being so, I've always been surrounded by water pollution, but I have never let it rule my life. Not many people can say that. Over 783 million people do not have access to clean water. How can this be? Well, the main problem is water pollution. So to be able to understand why this occurs, we need to understand where this pollution comes from. Looking at the slide, we can see a commonality between these icons. We can all tell that humans are involved in some way. But there are also other connections that you can make with these. You can make them into point pollution sources and non-point pollution sources. Well, point pollution sources are pollution that you can identify to a specific point. And this can include urban runoff, effluent discharge from sewers and pipes, and other such things. And then non-point pollution sources are pollution that you cannot track back to a specific place. And this includes fertilizers and pesticides from farms, erosion from riverbanks, recreational boating, and all that other stuff. So what is a real-world example of these two things coming together? The Ganges River in India. Looking at this picture, we can see the industrial, agricultural, urban waste products in the water. And I know everyone in here would not want to go into that water at all unless they had protective gear. So why would these people go into the water if it's this polluted? Well, stepping into their shoes, if this was the only place to get water in their area, you can get very desperate. So, this being so, let's look at another example of point pollution source. Looking at this picture, we can imagine standing on top of a mountain and looking down at a clouded landscape. But are those really clouds? In reality, this is the Tietê River in Brazil. Years of dumping chemical waste into the waterways led to the formation of toxic foam blocks that emit harmful gases. Animals, plants, and people that live near this water source have a higher chance of getting diseases and illnesses. To be able to understand how water pollution gets this bad, people need to understand the fragile balance between pollution sources and water sources. Because in reality, the Tietê River is not the only river that looks like the sky fell. Now, to make sure that we can do something about this, we can offer incentives to industries, farmers, and such. This can include tax credits, funding, creating partnerships. For example, if a government were to say to an industry, "We will give you a tax credit if you decrease your effluent discharge by 30% by a certain time. The industry will be more likely to try to do that. A tax credit is pretty much a government offsetting a group's amount of money they must pay for taxes so that they do a certain action. And so also funding, being able to fund industries to help them change their practices, to create new infrastructure to help them, and then creating partnerships with governments, with environmental organizations to help make this better. Now looking at this picture, this is a picture of my siblings and I, and we're standing in front of the Chesapeake Bay in Virginia. Looking out over the water, you don't really see anything wrong with it. You don't see anything that you saw in the Ganges River picture. But doing an aerial view, we see this. This is known as a red tide, or a huge toxic algal bloom. Now, this occurs naturally in nature, but it can get this bad when pollution is involved with it. And this process is known as eutrophication. So let me explain a little bit about the process of eutrophication. The Chesapeake Bay watershed goes all the way from New York all the way down to southern Virginia. As you can see with this picture, we have a lot of rivers and such that run into the Chesapeake Bay. And along these rivers, we have industries, we have natural erosion occurring, we have agriculture. And all of these different things dump pollution into the waters, no matter if it was on purpose or just by natural runoff. Now, with eutrophication, the main pollution that is involved is nutrient pollution, and a lot of this nutrient pollution comes from agriculture, specifically phosphorus and nitrogen nutrients. Now, when the nutrients run off into the water, the algae start to bloom because the algae feed off of phosphorus and nitrogen. However, as the algae bloom to a large extent, they start dying. And as they die, their carcasses float to the bottom of the riverbeds or oceans or whatever, and the pelagic species or bottom feeders start to feed off of these carcasses. However, when they start to feed off of these dead algae, they also start to feed off of the dissolved oxygen in the water. This is a bad thing because by them feeding off the dissolved oxygen, they lower the amount of oxygen in the water, creating something called a dead zone. A dead zone is where no animals or barely any animals can live because there is not enough oxygen to survive off of. This decreases biodiversity in the area, which in itself affects industries, especially in the Chesapeake Bay, where a majority of our industry is in seafood. Now, a more well-known example of this occurring actually occurs in the Gulf of Mexico. The Mississippi River runs all the way from the Great Lakes down to the Gulf of Mexico, and there's a lot of rivers that branch off of it. With this being so, and what we've learned about eutrophication along the Chesapeake Bay, there are industries, agriculture along these riverways that dump pollution into the water. The Mississippi watershed covers 41% of the continental United States. So all of the pollution that occurs within that area ends up in the Gulf of Mexico. Let's take a closer look of this colorful area at the bottom. According to NOAA, this area, this eutrophication zone, is about 7,286 and 8,561 square miles wide. This is about the size of New Jersey. Having a dead zone this large, you can see how it affects the biodiversity and how it's a negative effect to the industries and the people in the area. Now, this is a seasonal thing. It doesn't happen all year round, but let me explain a little bit about that. What this chart shows is that during the summer and winter, something called water stratification occurs, where the water starts to create layers because not enough wind and turbulence is occurring in the water. This is a prime time for eutrophication to occur, where oxygen is not allowed to mix in the water, causing dead zones to occur. However, in the spring and autumn, the water becomes more turbulent and oxygen is able to turn over or upwell from the bottom of the ocean. This is a time for eutrophication to be less likely to occur, but it can still occur during this time. Now, this problem is not just in the United States. This is actually a worldwide problem as well. This satellite image shows eutrophication across the world in green. This being so, we have to try our best to try to inform other people in other countries with the problems that occur with dumping pollution into our waterways. So, some incentives that we can get for non-point pollution sources: funding organic practices. Instead of having farmers use pesticides and fertilizers to make their crops grow, we should be able to fund these farmers so that they are able to create organic practices. Also, creating partnerships between environmental groups and these farmers and industries, and even community involvement with groups. If the community is more willing for this change to occur, the industries and farmers will be more willing to accept it as well. So when it comes down to it, it is very important that we understand where this pollution comes from, and that even though we may not physically see it all the time, it is still there, and that we want to do something to fix it, because one day we may wake up and realize that what we once had is no longer there, and what was once not ruling us is ruling us now. Thank you.